Hello everyone. This is the sixth week of our session on solving gate physics problems. And this is like the midway. So we have this is a 12-week course, and today is our sixth week in this series. And just as always, before starting, I will provide you with all the relevant links that are there. So first up, the most important link for all of you is the YouTube link. This is where all of these videos would be uploaded and as well as streamed live. So that's the YouTube link. Then we have the Google Drive folder where all of these lecture notes would be uploaded. So I'll share the Google Drive folder for you as well. So that's the Google Drive folder link. And then, sorry. So apart from that, we also have a Discord server which you could join. So I'll share the link. So that's the Discord server link. So these are the logistical details. These are the links that you should bookmark and follow. And these classes are 1:30 p.m. to 2:30 p.m. every Saturday. And the topics that we focus on are general aptitude, mathematical physics, electromagnetic theory, and quantum mechanics. So today we would look at so as always, we start with a few questions on general aptitude and then we move towards one of the three topics of mathematical physics, electromagnetic theory, or quantum mechanics. So today we will look at mathematical physics in addition to general aptitude. So let us begin with general aptitude. And as you must be aware by now that we do have some English language questions in general aptitude. So the first question over here is, choose the most appropriate alternatives from the options given below to complete the following sentence. So the sentence goes like, despite several dash, the mission succeeded in its attempt to resolve the conflict. So this is the sentence. We need to fill in the blanks. And it is pretty obvious that the correct answer would be that despite several setbacks, the mission succeeded in its attempt to resolve the conflict. And why so? Because the sentence is trying to say that despite facing several setbacks or several hardships or several difficulties, one is able to complete the mission. For option A to be correct, let's say we want to use the word attempts, then the sentence could have been, after several attempts, the mission succeeded to complete the whatever stuff they want to achieve. So here the word attempts is not appropriate. Similarly, the word meeting is not appropriate. The sentence with a meeting in it could be that after several meetings, the committee came to this kind of conclusion, something like that. And similarly, for delegations, it could be that after several discussions, the committee decided to delegate the task to different delegations. So these are how you would use all these four words in a similar context. But over here, the correct option is, despite several setbacks, the mission succeeded in its attempt to resolve the conflict. So moving over to the next question. The cost function for a product in a firm is given by 5Q squared, where Q is the amount of production. The firm can sell the product at a market price of rupees 50 per unit. The number of units to be produced by the firm such that the profit is maximized is, and we need to select the correct option. So let us solve it. So the cost is 5Q squared for an amount Q, So if amount is Q to be produced, then the cost is 5Q squared. Selling price is rupees 50 per unit. So that is 50 times Q, where Q is the amount and this is in rupees. So therefore, the profit is going to be selling price minus cost. So that is 50Q minus 5Q squared. That is the amount of profit that the company would make. And we need to maximize this profit. So maximizing the profit would mean that the derivative of profit with respect to the quantity should be equal to 0, and the second derivative should be negative. So let us solve it. So dp over dq is what? It is 50 minus 10q. So that means dp over dq equals to 0 implies that 50 minus 10q is equal to 0. So q is equal to 5. And you can clearly see that the second derivative is negative 10. So that's less than 0. So this point is a point of maximum. So q is equal to 5 is the point of maximum. That means one needs to sell 5 such quantities in order to make profit, in order to maximize the profit. So that is the number of units to be produced by the firm so that the profit is maximized. So next question. Here is another fill in the blanks type question pertaining to English grammar. So the question says, Suresh's dog is the one dash was hurt in the stampede. So if all of you could quickly type in the chat box what the correct option is before I tell you the correct answer. So A, B, C or D, just type in the chat box which is the correct option.
Recording in progress. Recording stopped. Recording in progress.
Okay, so someone is saying A, so someone is saying C. A lot of people are saying C. Okay, fine. Yeah, so 3 people have responded. 2 more. Could you please also respond, or else I would give you the answer. So this is a little bit tricky in the sense that sometimes what we say in colloquial language when we are talking to our friends, we are not that 100% accurate in terms of grammar. But when we write something, we need to be 100% accurate in terms of grammar. So the correct option over here is option B. Suresh's dog is the one which was hurt in the stampede. So who is not correct? Why? Because it is not Suresh's dog who was injured or who was hurt in the stampede. No, you don't use who in this kind of a context. Who is supposed to be like, who is the one who is trying to enter my room without my permission? That kind of a scenario you would use who. That is also not appropriate over here because this dog is a living thing, and here we are trying to find out which of the dog among the group of dogs got hurt in the stampede. So let's say there are 100 dogs. Out of those 100 dogs, which dog got injured in the stampede? So which is the correct word to be used here? It is neither that, it is neither who, and it is definitely not whom. So we are selecting one out of those 100 or maybe how many ever dogs that are there. So it is selecting one out of those items. That means which is the word which is supposed to be used over here. So Suresh's dog is the one which was hurt in the stampede. Next question. So which of the following assertions are correct? See, here also in the question we are saying which of the following assertions are correct, right? So we are trying to select one or two or maybe some out of these assertions which are correct. So this is the kind of scenario in which you use which. You do not use who of the following assertions are correct. Similarly, you don't say that of the following assertions are correct. You use which of the following assertions are correct. So when you're trying to select something out of a larger group, then you use the word which. So the assertions over here that are there are adding 7 to each entry in a list adds 7 to the mean of the list. That's the first assertion. Next is adding 7 to each entry in a list adds 7 to the standard deviation of the list. The third one is doubling each entry in a list doubles the mean of the list. And the fourth one is doubling each entry in a list leaves standard deviation unchanged. So, and options are either P and Q are correct, or Q and R are correct, or P and R are correct, or R and S are the correct assertions. So let us try and solve this. So by definition of mean, we have mean is defined as follows. If there are n elements, n measurements, let's say, then mean is defined as 1 over n summation of xi, where with I going from 1 to n. If there are n such measurements, then this is the mean of those measurements. Now, if in this, let's say I replace xi with xi plus 7, that is adding 7 to each of the elements. So this would give me a new mean as follows. So we can simplify this by separating the terms. So this first term right here is our original mean that we had defined over here. And the second term is 7 into n over n, because we are adding 7n times. So that would be 7n, and there is an n in the denominator as well. So this cancels. This gives me x bar plus 7. Similarly, when I take my xi to be 2 times xi, that is doubling each element. So when I double the elements, then what do I get as my new mean? That is C. So 2 is a constant, we can take it out. So 2 into 1 over n summation xi, and the summation xi over n is basically my old mean defined over here. So this is 2 times x bar. So adding 7 to each entry in a list adds 7 to the mean. This is correct. Then doubling each entry in a list doubles the mean of the list. This is also correct. So immediately you can see that P and R are the correct options without having to even check for the standard deviation. But since the question asks, these are also the options, so we will look at the standard deviation also, so that we are 100% clear. So standard deviation. Standard deviation is defined as follows. We have sigma is the standard deviation. So that's the standard deviation. So xi minus x bar are the deviations. So deviations from the mean. So we standard deviation basically tries to find out deviations from the mean. So xi minus x bar is your deviation from the mean. Then you take square of it and you add each such squared deviations, and then you take its mean, that is divided by n, and then you take its square root. So it's also known as root mean squared, because you are taking the mean of the square and then taking a square root of it. So that's the definition of standard deviation, which characterizes how much deviation from the mean your data has. So let us now see, if I take each element and add 7 to each element, what happens to my standard deviation. So that would be, so I'm adding 7 to each element, so xi plus 7, and then you know that mean goes to mean plus 7, so x bar will also become x bar plus 7, square of this over n, and then square root. So you clearly see that this 7 and this 7 cancels out, giving me simply my original sigma. Now, if I double each element, then what happens? Let us see. So what I'm doing is I am doubling each element. So xi becomes 2xi, and in such a case, mean also becomes twice. So that's that. Take its mean, take it. So here we can take 2 common from in this 2xi minus 2x bar. So if we take 2 common, then 2 squared, that becomes 4. So we have 4 over here. That is what we get, and square root of 4 is nothing but 2, and this remaining stuff is simply the old standard deviation. So we get 2 times sigma. So if you add some quantity to each element, your standard deviation is unchanged. If you scale each element by some factor, then your standard deviation also scales by the same factor. So now we will move to the next question. So the next question says, a political party orders an arch for the entrance to the ground in which the annual convention is being held. The profile of the arch follows the equation y is equal to 2x minus 0.1x squared, where y is the height of the arch in meters. The maximum possible height of the arch is, we need to select one out of these options. So that means maximum height means we need to maximize y is equal to 2x minus 0.1x squared, and this would occur when dy by dx equal to 0 and d squared y by dx squared is less than 0. That is, we need to find maxima of this function y is equal to 2x minus 0.1 x squared. So dy by dx equals to 0 implies 2 minus 0.1 into 2 x equals to 0, which implies x is equal to 2 divided by 0.2, which is 10. But this is not the answer. The answer is, at x equal to 10, what is my value of y? So at x equal to 10, y is 2 into 10 minus 0.1 into 10 squared, which is 20 minus 10, which is also equal to 10. and this is in meters, so it is 10 meters. So 10 meters is the correct option. So notice that x is 10 over here and y is also 10, but that is because of this question. It need not be that if x equal to 10 then y also has the same value. That need not be the case. So sometimes people find out the value of x and they assume that this is the correct answer and they tick according to that. So you need to be careful that x is the point of the maximum. X is not the maximum itself. So you need to be careful about that. And so point of maximum is the value of y where x is supposed to be maximizing that. And clearly you can see that d squared y over dx squared is minus 0.1 into 2, which is minus 0.2, which is less than 0. So this is indeed the maximum. So that completes the section on general aptitude. Now we move towards the section on mathematical physics. So the first question over here on mathematical physics is based on similarity. So two matrices A and B are said to be similar if B is equal to P inverse AP for some invertible matrix P. Which of the following statements is not true? We need to select the statement which is false. Sorry, I think some things got erased. Let me rewrite it again. So this was supposed to be sorry about that. So yeah, these are the four options and we need to select which option is not true. Now, determinant, this is a similarity transform, okay? So this is what is known as similarity transform, and determinant and trace are preserved in a similarity transform so determinant and trace are the same because they are preserved, and B is equal to P inverse AP. This is also used for diagonalization. So this is used for diagonalization as well. And in the case of diagonalization, what you get is that diagonal elements of B are the eigen values of A. So eigenvalues are also same. So the statement which is not true is statement 3, that they have the same eigenvectors. They do not have the same eigenvectors, but they have the same eigenvalues. So let us look at it a bit more mathematically. So let me say I want to find out the eigenvalues of B, what the eigenvalues of B are. So B minus lambda I is P inverse AP, that is because B is P inverse AP from the similarity transform. So B minus lambda I, so that means P inverse AP minus lambda I. So this, what we can do is, we can multiply P inverse P. Why? Because P inverse P by definition of the inverse is identity matrix. And then what we can do is we can take some factors common. So P inverse A minus lambda I P. because P inverse is left multiplying A and P is right multiplying. So, and then same for lambda I. Lambda is a constant. It can go inside. So, lambda can be taken with I because lambda is a constant. Now, determinant of B minus lambda I. So, determinant of B minus lambda I is determinant of P inverse A minus lambda I times P, and determinant of a product of matrices is simply product of the determinants of the individual matrices. So here we can split it up as determinant of P inverse times determinant of A minus lambda I times determinant of P. And then since a determinant is just a number, we can rearrange. So we can write it as follows because this is just a number. And then we can combine these two. And this P inverse P we know is identity matrix. So this is simply determinant of A minus lambda I times determinant of I, and this is equal to determinant of identity matrix is simply 1. So this is nothing but equal to determinant of A minus lambda I. So what this implies? This implies that A and B, both these matrices have same characteristic equation. So same characteristic equation implies that the roots will also be same. So same roots. And what are the roots? The roots are eigenvalues. That means the eigenvalues are same. And we also know that trace is nothing but sum of eigenvalues. So if eigenvalues are same, then sum of eigenvalues would be same. So trace would be same. And determinant is nothing but product of eigenvalues. So if eigenvalues are same, then its product will also be same. So trace is same, determinant is same, eigenvalues are same in a similarity transform. So, but eigenvalues are same. That does not imply that eigenvectors will also be the same. So eigenvectors can definitely be different. Moving over to the next question. The question says that the unit normal to the surface x squared plus y squared minus z equal to 1 at the point P1, 1, 1 is, and we have 4 options. We need to select the correct option. Now, normal to a surface is given by gradient. So we need normal to a surface at any given point is the gradient of that surface at that particular point. So surface is what? Surface is given by x squared plus y squared minus z equal to 1. So we form the function for this surface as follows, and then we need to find out the gradient. So gradient is given by a grad of f, which is del f by del x I cap plus del f by del y j cap plus del f by del z k cap. Okay, and this is nothing but 2x I cap plus 2y j cap minus k cap. Now, gradient of f at the point P is 2i cap plus 2j cap minus k cap because P is the point 1, 1, 1. And this is my normal to the surface at the point B. And then unit normal. So with this also you can clearly see that this would be the correct option, because normalizing is just a scaling factor, but still we will find out the normalization. So unit normal means normalizing it, that is dividing it by the norm. So norm is 2 squared plus 2 squared plus 1 squared and then square root of that. So this is 4 plus 4 plus 1, that is 9, and square root of 9 is 3. So 2i cap plus 2j cap minus k cap over 3. That's the correct answer. So normal is given by gradient. And this is also the direction in which your function would decrease with the greatest rate. So that's that. That is about gradient. So moving further, which of the following statements is true for the function fz is equal to z sine z over z minus pi whole z minus pi squared? So these are the options and we need to select the correct option. So the correct option is option C. Why? Because A says fz is analytic everywhere in the complex plane. So someone is writing option B. Okay, so yeah, no worries, no need to say sorry. Option B is not the correct option. Option C is the correct option, and we will see why it is correct. So option A says that fz is analytic everywhere in the complex plane. Now this is incorrect. Why? Because denominator of this function goes to 0, which implies it is not analytic. If the denominator goes to 0, then your function will have indeterminate values at those points, and that means it is not analytic. Analytic function should not have any indeterminate values anywhere. So the next option says that fz has a 0 at z equal to pi. So this is incorrect. Why? Because again, same reason, that denominator goes to 0 at z equal to pi. So the so actually the 0 of this function would be at z equal to 0, because at z equal to 0 my denominator is non-zero and my numerator is 0. So this is option C, says that fz has a pole of order 2 at z equal to pi, and that's the correct option. Why? Because what is my denominator? Denominator is z minus pi squared. So because of this power 2, we have a pole of order 2. Had it been z minus pi to the power 4, then it would have been a pole of order 4. Had it been z minus pi raised to the power 999, then it would be a pole of order 999. So, and option D says that fz has a simple pole at z equal to pi. That's incorrect, because as we saw that order of z minus pi is 2, so pole of order 2. For it to be simple pole, this would be if the denominator would have been simply z minus pi. So simple pole means order 1. So simple pole means order 1. Okay. So someone is saying that it is simple pole because 0 by 0 form. No, that is not the thing. We need to see at z equal to pi. So had it been z over z squared, then you would have said simple pole. But you are looking, so had it been, let's say, uh, z over z squared like this. So had it been something like this and you were looking at, let's say, z equal to 0, then that would have been a simple pole. Okay. So you need to look at what your function is and where you are looking at. So you are looking at z equal to pi. So for that reason, and then in the denominator you have z minus pi whole squared. So that means it is a pole of order 2 in this scenario.
Ma'am, but sine pi is also 0. No? So 0 by 0 form it will take, and then you have to check.
Sorry?
Sine pi is also 0 in the numerator, and so we have to check for if it considers single pole or double pole. Because if we put the limit, then we got a 0 by 0.
Yes, that's right.
So we have to check.
Sorry, you are saying something and then you are stopping. Could you please say again?
We have to take limit z minus z0 is pole, and take the power m. If it is a pole of order m, then and then do the calculation. If it is finite, then it is the pole of order m. So here we can do z minus x into the function and check if it is finite, then the pole order will be simple.
Okay, so you are raising a very important point over here. So you are saying, I think I understand your query. So you are saying that we are looking at this, and since we have like this, then you are saying that it is like something like pi, sorry, something like 1 0 and then z minus pi both 0. So in that sense you are saying that this should be like, so it is a 0 by 0 form. So you're saying that we will look at it as a simple pole only, because you can think of it like one term cancelling out with one term or something, means in a very layman kind of language. So this is the reason you are trying to say that this is a simple pole. Am I right? Is this what you are trying to understand and think in this direction? Hello?
Yes, ma'am. I was thinking that.
Yeah, so Rituraj, you are saying like this, right? Yeah, could you just say if I have understood your query correctly?
Yes, ma'am. It is
Okay,
correct.
so I think I will check this out properly then again as the definition of the pole. As far as my understanding about poles goes, that we look at the order in the denominator, then in that sense this should have been order 2, and this is also given as the solution to the gate solution. So I would just check this thing out once again. So this is like some previous year, I think gate 2011 question, and the solution key provided with that has this also as the option. So I will clarify this with you in the next class. So this question, this is a very important point you have raised. So I would check out once again as to why they provided this solution, or if some error was there in that year or something, and as to whether how we consider for something to be a simple pole by looking at the
Ma'am, we
numerator.
can also expand the numerator in the form of about a point z
Yes,
equals
we
to
can
pi,
do the
and then
Taylor, we can do the Taylor
check their
series expansion.
pole.
You are right. So we can do the Taylor series expansion and so on and so forth, and we can.
But about the point 5, I am saying.
So yeah, you need to do about z minus pi, right? Because we are looking at the point pi. So you need to do sine z, but about in terms of z minus pi, right? Hello.
Hmm.
Yeah. So I think I will clarify this thing in the next class with you as to the precise definition and why this was given. Then let me just clarify once again with the previous year's gate answer key, and then I'll get back to you in the next lecture. Yeah, this is a very good point actually you have raised. So this is important and this needs to be fixed. So yeah, thank you for pointing this out, and I will make sure I clarify this thing with all of you in the next lecture. So now we move to the next question, which is also based on this one. So it says that consider a counterclockwise circular contour mod z equal to 1 about the origin, and let fz equal to z sine z over z minus pi squared, then the integral of fz dz over the contour is. Now without even doing anything, you can say that the answer is 0 without even doing any calculations. But had there had some other contour been given and had some other function been given, then you need to know what is known as the residue theorem. So residue theorem is given as follows. So if you want to find out the integral of some complex valued function over some closed contour C, then this is given as follows: 2 pi I times sum of these residues. So these are residues, these are the sum of residues, this a minus 1, b minus 1, c minus 1. And how we find out these residues? So if fz is what? Fz is a complex valued function, and this is supposed to be single valued, analytic. So it will be analytic everywhere except, so it is analytic inside so it is analytic inside as well as on some simple closed curve C, which is also the contour, except, so it's analytic everywhere except at singular points. So these are the singular points which are inside the curve C, and these singular points have residues given by a minus 1, b minus 1, c minus 1, and so on and so forth. So what are the residues? Residues are given as follows. So this is how you would find out residues for when your z equal to a is a pole. Pole of order k. So this is how you would find out the residues. But now when you look at your function, this is your function, and this is having singularity. Your singularity is at z equal to pi, and your contour that you are given is mod z equal to 1. So if you look at it, this would be -1. This is a circle, basically, unit circle. This is like your contour is a unit circle, radius 1 and centered about the origin, this radius being 1. So this is your contour, and z equal to pi. So if this is 1, then your pi would be like somewhere over here, which is clearly outside this contour. So z equal to pi, which is your singularity, is outside of your curve. It is outside of C. It is not within C. And therefore, your integral over the contour is simply 0. Had your singularity been inside the curve, you would have found it out using this expression. But if your singularities lie outside the curve, then there is no point of calculating anything. The value of the integral would be 0, because the contribution to the integral comes only from the singular points. Finally, we have the last question. Identify the correct statements for the following vectors A and B. We need to see whether they are linearly dependent or independent, whether they are orthogonal or whether they are normalized. Now, linear independence is given by the following conditions. So if you have some vectors vi, and if you take the linear combination of them, and if the linear combination equals to 0, and if this implies that all of your coefficients alpha I in the linear combination are 0, that is, it is also known as trivial solution, then we have linear independence. And if we have non-trivial solution for alpha I, then we have what is known as linear dependence. So this is linear dependence and independence definition of it. And in 2D, in 2 dimensions, if your vector v1 is parallel to v2, then they are linearly dependent. Else, they are linearly independent. Okay. So from the options that we have, 3i cap plus 2j cap and I cap plus 2j cap, we can clearly see that A is not parallel to B. That means A and B are linearly independent. So the correct statement is that A and B are linearly independent. And for orthogonality, if you check A dot B, that is 3 into 1 plus 2 into 2, which is 13, which is not equal to 0. That means they are not orthogonal. And for normalization, norm of A is nothing but 3 squared plus 2 squared square root of it, and that's square root of 13, which is not equal to 1. Similarly, norm of B is like so, square root of 5, which is not equal to 1. which implies they are not normalized. So the correct option is that the vectors A and B are linearly independent. So that completes today's lecture on mathematical physics and general aptitude. Next week, we will look at electromagnetic theory. So this is how we cycle. We start with mathematical physics, electromagnetic theory, and then quantum mechanics, and back again to mathematical physics. And important point raised by Rituraj, I guess, today is regarding the simple pole. So Rituraj, are you on the Discord server?
Yes, ma'am.
So, okay, I will clarify this thing and I will put it on the Discord server as well. And we will start with this question in the next class and I will clarify it for others as well regarding this question and this definition of a something being a simple pole or not. So, thank you very much for actually raising this query. And this actually helps me also to go back and try and clarify certain things and revise certain things which might have become rusty by now. So yeah, thank you very much actually. So that's all for today. And if you have any more queries or concerns, you could ask them over here or on the Discord server. Notice the use of which here as well. So remember that general aptitude question in which we were supposed to use which. So if you notice over here, here also the word which is being used instead of the word that being used. So someone had said as an answer to a previous grammar question that it should be that Suresh's dog was the one that got hurt. But I said no, it is which got hurt. You notice the use of which here as well. So this is a typical error that some people have. They basically interchange that and which should not be done. So be careful regarding English grammar as well. So that's all, and thank you.
Recording stopped.